Hello, and welcome to this talk on content graphs. This is the first in a two-part follow-up to an earlier talk where I showed how to classify content in a content management system with concepts in a pool party taxonomy using the product Fonto.xml. In that earlier talk, I showed how you could take a piece of content and link it to matching concepts from a pool party taxonomy. The Fonto.xml editor tags content directly by adding markup elements around the text, and in this way you can link a content item to a taxonomy. The element points back to the original concept stored in pool party via its URI. You can use this method to classify your content items on the fly and improve your content management processes. Now this approach is great. It's an order of magnitude better than simple tagging against an internal taxonomy, which, let's face it, is the only option you have with most content management systems. But I think that there's more that we can do. If we look at a typical integration between a CMS and a TMS, it requires that your tagging and your markup are embedded right there in the document, and this in turn means that your classification is buried in the CMS, it's hidden. You need to do software development to customize your system, and your content is bespoke. Its tagging and the actual content may be difficult to migrate to a different CMS in future. But what if you didn't have to do this? What if you had a way in which you could take the classification out of the CMS and store it somewhere else? If you did this, you could gain some real benefits. Your content would remain untouched in the CMS, so you don't need to do a load of coding, and future migrations would be simpler. Your taxonomies would be commonly available across your business, so that they're available to any business application as a single source of truth. And your knowledge would be available right the way across the business as well, enabling you to build a knowledge network with a common mechanism to get at all of your information wherever it is. Now today I'm going to show you how you can do this, and here's a summary of what's coming up. First, we need a content store. I'm using a Drupal website here. It's a real-life website that stores thousands of pieces of high-quality curated legal content. There's nothing special about Drupal, by the way. In this case, it's a convenient example of a content library that's accessible via the web. Everything I'm talking about today should be just as applicable to other content management systems. Second, we need a taxonomy, and that will provide us with our classification concepts, and that's pool party. Over in the pool party server, we've built a taxonomy that's tailor-made for this legal content. I'll briefly show you this in a moment, and in a future talk I'm going to come back and describe how we built this, because it's an interesting story in itself of text mining within a knowledge domain, and it shows how you can make a taxonomy that's relevant for the knowledge domain that owns it. That'll be for another day though. The third component we need is something to glue these systems together. This is our Content Graph Explorer, and I'll give a demo of that shortly. This is an application that we've recently developed in order to integrate Drupal and pool party. Think of this as a go-between that knows how to talk to each of the other components. Now, so far there's nothing new here, and there are a number of existing integrations between various content management systems and pool party. Where this differs is how we're storing the classification. Instead of the classification being stored buried in the content, we're extracting the tagging event. And for this, we need a fourth component that we will use to build what we're calling a content graph. And that fourth component is a triple store, and we're going to use that to store our classifications. Now I'm going to go into this in a lot more detail later in this talk, but for now just think of the triple store as the place where we're storing the classification or tagging fact. I'm going to step out now and give you a live demo of the workings of the Content Graph Explorer, and then I'll come back and we'll take a deeper dive into the underlying technologies. I promised to show you the taxonomy that we're using for today's work, and this is it. We created this using Pool Party. You can see that we have a number of concept schemes over here on the left, which aggregate sets of concepts together into logical groupings, subjects, regions, and so on. I'm not going to go into great detail today about how Pool Party works or its features. There's plenty of stuff on the web that you can look up for that, and you can look at earlier webinars of mine as well. For now, suffice to say that this Pool Party taxonomy provides a set of concepts that are going to be used to classify the content in the Content Explorer, and that's where we're going next. This user interface shows the Content Graph Explorer. Think of this as the go-between that I mentioned earlier on, a standalone program providing windows into both your content management system and Pool Party. Here's a list of documents managed in the CMS. As this application loads, it makes a call out to Drupal and retrieves a list of articles from the library. There are many thousands of articles in this library. You can see it's about 20 here and 170 pages of them. Each article title shows some simple metadata, and this is just to illustrate that this is the kind of thing that a CMS would give you: titles, dates, authors, that sort of thing. Now, if I choose a document, say the Tellura report, the application goes and fetches the body of the article, but it also does a little more. It also sends the content of the article off to Pool Party and retrieves a set of concepts that Pool Party thinks are relevant for this content. This process uses the Pool Party Extractor API, and it happens in real time. The concepts that Pool Party has retrieved appear on the right hand side of the page, marked by these checkboxes, and I can choose the ones that match. So let's say that working as an editor, I've decided that the right matching concepts include things like Taylor Review, Agency Workers Directive, National Minimum Wage, and so on. And you can obviously see, because these are already checked, that I've been here before and I've pre-checked some of these. Notice that the tagging suggestions are grouped into sections. These correspond to the concept schemes that we previously built in Pool Party. Indeed, they're directly loaded from Pool Party, just as the concepts are. And they're there so that you can see the context in which a particular concept is being offered, not just a keyword. For example, if I check the national concept, I know that I'm defining this in a regional context, not as a subject or a legal term. Now, I want to show a couple of other things with this example. As a subject matter expert, I might know that this article is on a particular subject, but Pool Party hasn't suggested the subject as a tagging concept. This might happen if the subject doesn't appear at all in the article, or it might happen if the concept doesn't yet exist in Pool Party. We can address each of these cases. First, suppose that from reading this article we know that it's about the gig economy. The phrase doesn't exist in the article, but all the same, our gut feel from reading it is that that's a subject matter. Now, if it's not retrieved by the extractor, then we can go and have a look and see if it's there. So we can use the find box to start to type in a phrase, and Pool Party will deliver to us the labels for any concepts that match that. So we can say select gig economy, and it's stored temporarily in this sort of pending area. And when I save it, that moves up into the subject list. There we go. Secondly, let's suppose that I think this article is also about dependent contractors. Now, we can go and look for it, and we're not getting anything. This concept doesn't actually exist in the pool party taxonomy, but as a subject matter expert, I might think this is a concept that we really should have in our taxonomy. So I can use a rather neat feature of pool party and suggest it as a new concept. And because I'm sending a note to a pool party admin, I should also put in an explanatory note. And when I click on the send button, I get a message confirming that it's sent. Now, it's worth emphasizing that I haven't added a concept to pool party at this stage. I don't have the rights to do that. I'm a subject matter expert and a content editor. But if I swap over to pool party and adopt my alter ego as a pool party administrator, then I can go to my dashboard, and under the suggested concept section, I'll see the concept suggestion that I've just made. And as administrator, I can now place this in the taxonomy wherever I want it. So if I just select this now, I think this is probably a more precise concept below contractor. So I'm going to go and look for contractor, and I'm making this thing, dependent contractor, a narrower concept of it. So I click on add, and this shows me the confirming page within pool party, and you can see if I go to the contractor concept, then it's got a narrower concept of dependent contractor. Back in my content system, I've been informed by the administrator, and I now know that dependent contractor is available as a concept. So if I now do a search, there's dependent contractor, and I can save that. Of course, I've compressed this bit of business workflow into just a few seconds, but you can see that this ability to be able to tag dynamically, to be able to go and find concepts that haven't been suggested, and to suggest new concepts, all add genuinely useful tools to content authors and editors. Now, when I'm finished classifying this document, as you've already seen, I can tap the save button, and you might think that when I hit that save button that the document gets saved back into Drupal. In fact, it doesn't. It doesn't need to. We don't need to save the content in Drupal at all. We don't touch the content in Drupal, in fact, apart from reading it here. This is the key point that differentiates this approach to classification from traditional tagging. Instead of storing the classification in the content, we've created a new piece of information, a semantic triple, that simply captures the classification that we've just defined. A good triple will have a subject, and there's the URI for the subject, which is this piece of content. It will have one or more concepts, and the URIs for these concepts are held in pool party. If we look at let's go and have a quick look at dependent contractor, then you can see that this has a URI. There it is. And although it's not spelled out, these subject references here, when we've linked to them, we have an underlying information model that is used to create the predicate. So it'll be something like has region, pointing to the concept for national, has legal term, pointing to agency workers directive, has concept for the subject section, and so on. So we've got our semantic triple in effect. So as I work through my collection of documents, classifying each one, I'm building up a collection of classification facts. This one is about employment tribunals. This one is about the European Court of Justice. This one is about toupee, and so on. Each of these is a semantic triple, and together they build into a knowledge graph. Okay, then that brings me to the end of this live demo of the Content Graph Explorer. In the remainder of this talk, I'm going to cover semantic triples and content graphs in more depth. Now that we've seen the Content Graph Explorer in action, I'm going to round off this first part of the talk with a brief introduction to semantic triples. If you've heard me talk about this topic before, forgive the repetition, but it's an important building block of what we have to talk about a bit later on. Imagine a simple sentence in English: John likes curry. Now imagine a few more. John likes beer, John hates pizza, Janet hates curry, John knows Janet. Each of these sentences has a subject and a verb and an object. The verb provides some meaning to the link between the subject and the object. It's a semantic link. Now, a semantic triple is just like one of these sentences. To create a triple, you define a subject, a linking predicate, and an object. So, John likes curry could turn into a triple that has an object called John, a predicate called likes, and an object called curry, all drawn from an information model. As with an English sentence, the predicate provides the meaningful link between the subject and the object. We're not going to go into information models in detail today, but the design of these is crucial to the correct working of these components. In essence, the model, or the ontology in semantic speak, creates the scaffolding and rules for you to build your information into meaningful content graphs. Looking again at our collection of sentences, something that jumps out to us is that there's a lot of similarity between these sentences, and maybe we can explore that similarity. There are a lot that feature John, a lot that feature Janet, and there are others that feature curry and likes and hates and so on. If we could put a collection of these structured sentences into a common location, we could look at them all together and ask questions such as: what things does John like? Who likes beer? Who knows John? What do Janet and John have in common? This is exactly the kind of thing that we'll be doing when we build a content graph, and we can think of a content graph as a knowledge network that links up the things that we know about. Here's an example based on the sentences that we've just been looking at. We have entities like John and curry and Janet and beer and pizza, and we have predicates that link them together. In fact, these predicates have a little bit more detail that we could probably look at here. Notice that John likes curry, but that arrow only points one way. Curry doesn't like John. That's one of the rules that we build into our ontology. Similarly, John knows Janet. That's a double-headed arrow, and that represents a symmetrical relationship, implying that if John knows Janet, Janet must know John. So we can use these collections of triples to build up a knowledge graph like this, to allow us to make interesting observations and insights into the information that we're storing. Well, this brings me to the end of the first part of this talk. In the second part, I'm going to show how to apply this kind of reasoning to our content management example in order to build and use a content graph. So please come back soon. Bye for now.